All right, for our next presentation, I'm very excited to introduce to you Dr. Larry Heck, who will be speaking on, this is a fantastic title for a presentation, he'll be speaking on separating fact from fiction, fears from reality, and hype from progress in AI. Dr. Larry Heck is a professor of electrical and computer engineering at Georgia Tech. He holds the Raisa S. Farmer Distinguished Chair of Advanced Computing Concepts and is a research scholar at Georgia Tech as well. Larry is a fellow of the IEEE and has received the Distinguished Engineer Award from the Texas Tech University. Ladies and gentlemen, join me in welcoming Dr. Larry Heck to the stage.
Good afternoon. So I am here in much pleasure to be able to talk about the most recent version of AI. For me, this is interesting because I've been working on AI for a long, long time. And this question that I'm posing in this presentation is something that I've been asked probably at least 3 or 4 times over decades. So I've been working in the field for 30 years. To give you a little bit of my perspective, let me actually back up and talk about the history of AI really quickly, and the kind of things that I was doing at that time. So way back in the 80s when I started in grad school, I actually was at Georgia Tech, we were just coming out of the first AI winter. And at that time, you did not say you were working on neural networks, even though they existed in the late 80s. Instead, you said you're working on expert systems. In fact, Texas Instruments was funding my PhD. But I was actually working on neural networks. Some of the early papers were coming out in 86, 87. And a lot of the work was going on in neural networks was actually happening in speech recognition. And so if you want to go back and look at some of the earliest, most significant work in machine learning, look in the area of speech recognition. Many times the titles of the papers won't say that it was inventing a new machine learning technology, but it's there. So we were very much pushing the state of the art in what was not considered AI at the time, machine learning neural networks. And then the second AI winter happened in 1990. That was right when I was graduating. But for us, we kind of stayed heads down. We continued to work in speech processing. What I'm showing at the bottom is this is an example of probably the earliest paper in deep learning for speech processing. It was in 1998. That's about 14 years earlier than probably you think. At the top is one of the very first office assistants. It's a voice-driven assistant at Stanford Research where I was working alongside of a person named Adam Cheyer. Adam went on to found Siri. And then in the 2000s, I sort of was splitting my time in that decade between continuing speech processing, where my group at Nuance, we were commercializing the technology, split. We were acquired and my group split. Half went and started the Google Speech team in 2005. I went to Yahoo and they brought me in to run search and ads quality for Yahoo. So I spent about 4 or 5 years in search and ads quality, which again is another very sophisticated AI technology. We were introducing machine learning into the search relevance side. And then after I was working at Yahoo, many of us that were there in the search group, when Microsoft was going to acquire us, and they didn't happen, we went to Microsoft. And so I started the Cortana effort at Microsoft. I also was an advisor for a little company called Yap. Yap was acquired by Amazon. That became Alexa. And then I mentioned my friend Adam at Siri. Much, much later, outside of the scope of this, actually in 2017, I became the head of Bixby North America. So this area of large language models has actually been around for a while. So this was 2015, in that time frame, I was at Google Research. And this is after I'd been at Microsoft Research. At Google Research, I was in the NLP team. And we had an offsite in San Francisco where one of the members of our team stood up and said, I want to build one model for all of natural language processing. And so we had a lot of discussion about that. That turned out to be what's called transformers now. And that led into the more recent versions of transformers, the generative pre-trained transformers, or so-called GPT. And then now we're all learning about this as a community, ChatGPT. So the point I'm trying to make is that this technology is actually not something that suddenly appeared. It's been evolving and growing fairly steadily over time. And that's something to keep in mind when we're thinking about, the hype and the fear and the reality. However, having said that, there was a surprise, I think, to us that were in the natural language processing research community about just how much intelligence a large model can gain from that amount of data that was finally put into the systems in the last few years. And so there's been a lot of work, a lot of research actually going on right now to understand exactly where that threshold, that crossover happened when intelligence started to emerge in these different forms in terms of the amount of data. And so some forms of that intelligence is things like ChatGPT passing the MBA exam at Wharton, being able to pass the bar exam, AP biology exams, this sort of thing. So that kind of emergent intelligence is something that we're very actively studying right now, exactly what's going on. Now, with respect to the fears I'm showing here, I like this picture. It's a robot and a child. Will workplace robots cost more jobs than they create? Does rampant AI threaten humanity? And then Stephen Hawking warned of AI and it could end mankind. But wait a minute, that was a while ago. Stephen Hawking said that. That was 2014. Okay, so all three of those were 2014. You've heard the same thing here in this last year, just in the last few months, repeated again. I'm not dismissing those fears. There's absolutely reasons for us to be investing in technologies to address these concerns and fears. But I am saying it's been with us for a long time. This is back in 1983. Even way back in, what is that, 1844, what hath God wrought? So the question is, at least from my opinion, what's the reality of the current AI technology, and where's that reality coming from in terms of our evolution? So I'm going to give sort of hopefully a balanced view of this. This is going to be a bit skeptical on this slide to tell you kind of what problems remain. The first one is the technology in this era is relatively closed. So there's only a few large tech companies that have the dollars to actually do the compute. And I can say that now because I'm a professor. I'm no longer in these large companies. We don't have access to that. We don't have the money for that. These large language models lack transparency and control. So open AI companies are no longer open. And then these very sophisticated models that can pass the bar exam at the same time make really stupid mistakes. Hallucinate facts, they repeat the mistakes over and over. You can't correct them. And they lack common sense. And this is actually an area of research for my team at Georgia Tech, is how do we imbue common sense and how do we address these simple mistakes so that the systems are accurate when they need to be accurate. Common sense is not so easy. It's easy for us, but it's hard to imbue that into AI systems, and it's been historically hard. I like this quote: "Common sense is genius dressed in working clothes." So let me give you a couple examples of the lack of common sense in ChatGPT right now. So here's one example. So this is a question I posed to ChatGPT just a couple days ago. The traditional way to make raisins is to lay them out flat and dry them in the sun. Assuming it takes 3 hours to dry 10 raisins, how long does it take to dry 30 raisins? Okay, so I think everybody in the room would say, well, the sun is going to get to all 30 raisins at the same time, so it should take the same amount of time as 10. Here's what ChatGPT says. And it keeps going. And it keeps going. Really sounds sophisticated, really knowledgeable, and it comes up with the wrong answer. Okay, so common sense. So here's another example. This one I borrowed from Yejin Choi. Would I get a flat tire by bicycling over a bridge that is suspended over nails, screws, and broken glass? So we would all say, well, it's a suspension bridge. It's over this. No, of course not. Here's what ChatGPT says 2 days ago. Yes, bicycling over a bridge that is suspended over nails, screws, and broken glass is very likely to result in a flat tire and so on and so on. So you kind of get the idea, right? So there's still a lot of room for improvement areas that we need to be studying, and I have my PhD students actually working on how do you actually imbue this kind of common sense, which we take for granted. So what does all this mean? The common sense is just one thing of many hallucinations and problems that you've seen and we've heard about. Well, what it leads to is a lack of trust, particularly in the enterprise when you're trying to use this kind of technology where it really matters that you're precise, that you're correct. Okay, so what do we do about that? How do we actually gain that trust in AI now that we have these very large conversational open systems? So this is an example of collaboration. And this is kind of a reference to actually the previous talk in terms of hybrid AI technology. And this is a shoemaker, and you see the master shoemaker is on your right and the apprentice is on your left. A lot of the problem that we have right now is that we consider that the AI is actually the master and we're the apprentice. So we're sort of asking the AI, give us your master view of how you do X, Y, and Z, right? So one way to gain trust is to leverage that AI, but switch it so that the AI is actually in the apprentice role. We're in the master role, so we're in the control. How do we actually do that? Well, let me draw another analogy here. I'm going to remove the apprentice, and I'm going to bring up Iron Man. So this is more of how I think about it and how my students think about AI technology right now. Iron Man, as a person, is a regular human being, sort of, other than the thing that's implanted in his chest. It's the suit that actually makes him superhuman, right? But the suit is under his control. So this kind of mentality of humans plus AI, AI empowering, augmenting, and enhancing humans is the theme of my research lab at Georgia Tech. So another way of thinking about this, I draw inspiration from a book that Bill Gates put out. I think this was in 1999, called Business at the Speed of Thought. So Business at the Speed of Thought, that book was all about the role of technology is not to automate everything for us. It's to take our thoughts about how we want to run, in this case, the business, and translate them into operational programs, right? So getting rid of that impedance mismatch between how you're thinking about running the business and how you execute. So I really like that, Business at the Speed of Thought. And I'm thinking about that more broadly and thinking about that from a research perspective. What we really want to do is we want to be augmenting humans with AI so that, for example, for my graduate research assistants, they have help in reading all the papers that are coming out almost weekly now in the archives in this field of large language models, so that the AI can read the papers and they can have a discussion with those scientific papers about, okay, can you summarize this? Where are the missing pieces? Where are the opportunities for research? So a research assistant at the speed of thought, or a teaching assistant at the speed of thought in the classroom, in teaching a graduate class, let's say. My wife's a lawyer. She plays with ChatGPT every once in a while, and she reminds me that there's still a lot of work to be done. It's important that you're precise when you're calling up case precedents. But legal research at the speed of thought, it's augmenting humans. Medical research at the doctor's assistant at the speed of thought. And even in the creative areas, so I'm actually working on this at Georgia Tech, a composer's assistant at the speed of thought, or an artist's assistant or a writer's assistant. So the idea is we need to be augmenting humans with this technology, but to do that, there's a lot of technical challenges to solve to make it so that this partner of ours, this Iron Man suit, is compatible with not just our language, but how we actually live our lives, right? So there's a lot of work to be done, but the key is we didn't make sure that the humans actually are able to provide this kind of explicit feedback and teach the AI specifically for them, not just generically, and I'm talking about here the end users, not users that are humans that are hired by, let's say, OpenAI to refine the models. I'm talking about when the system's deployed. So I'm going to show a quick video. This video I actually put together 5 years ago when I was just leaving Google and I was recruited by Samsung to come in and help jumpstart their AI efforts. But it was one view of something that we were thinking about doing at Samsung. We actually ended up doing it at Georgia Tech.
Hey, Bixby, help me find an anniversary gift for my parents.
How about flowers?
Nah, traditional one.
I'm not sure what a traditional gift is. Can you show me?
Go on Wikipedia, search traditional wedding anniversary gift.
I found wedding anniversary on Wikipedia.
Okay, scroll down. Scroll down. There.
Okay, I'll remember that. Since it's your parents' 30th anniversary, how about a gift of pearl earrings and mother-of-pearl cufflinks?
Perfect.
Here's a selection of earrings and cufflinks.
Start.
Bixby learns new capsules from everyday interactions with millions of users on every kind of device. From Family Hub to all of Samsung's products, Bixby brings the multi-device experience to life.
Okay, so that was a vision video when I came to Georgia Tech, and we made it a reality. So I had one of my PhD students working on this. We published a paper recently on this. So this is the table that the person was looking at. Subtle, but the AI failed in the middle, and typically with current personal assistants, the system would have said, I don't know how to do that, I'm still learning. End of conversation, as opposed to what we're showing here is, can you teach me? So this is one of many different things that we're doing. And the conversational model that we're creating at Georgia Tech, we're focusing on conversational content like tables. We're also looking at smart glasses, conversational vision, leveraging that context. Conversational knowledge, common sense being the most basic. And then conversational expression, where we're actually building photorealistic 3D digital humans. So you can look more, you can look at in my Google Scholars page, or you can look online and you can see papers that we're publishing. Here's the conversational tables paper. This is one of the papers in conversational vision, and then this is something that we just published on common sense. Thank you very much. Yeah, any questions?
Gentleman just here. Microphone's coming.
Yeah, that is. Hello, yeah, Dennis Jorin, Data Consulting Director, Artifact. So I think you mentioned, one big topic is common sense. And if I saw at the end, one part of that would be context. So I think that's being very actively improved, how we can bring in context. But I think one part is also analytics. So for example, the models are language models, so they're not really trained to do actual analytics, like, oh, the bridge is like this. So do you also foresee like big jumps in that area in the coming time? Or?
Yeah, so that's a good question about leveraging analytics. So in every system I've ever been involved with deploying since 2005 or 2002, it's always been a hybrid system. And we've leveraged things like analytics as part of our speech solutions or part of search, all the way through. And I see that growing significantly right now, particularly because the enterprise now has the ability to have support natural conversations over content and be able to do some precision calculations. And I think it's important that we solve that problem because the precision in the large language models is not necessarily there for analytics.
Thank you.
Okay. We have a time for one more question, I believe. The gentleman just over there in the dark shed.
Thank you. I'm Shailendra from NEOM. One question. First of all, thank you for that. And expert systems, we did it in college as well. I still remember. You just reminded me of the college. One thing is about linguistics. So what are we doing around that? Because every time I speak into the phone or my car and ask it a question, it says, can you please repeat? I don't understand. What is being done about that?
Yeah,
I think that is very important.
The role of linguistics?
Yep.
Yeah. So I think in the broader area of expert systems and linguistics and these technologies that were big in the 70s and 80s, I think we're going to see a back to the future. I think that one of the reasons why we had difficulties in the past, we were trying to build up these AI systems that were robust to all conditions using syntactic and semantic parsers and everything that we could know about linguistics and grammar. But we're approaching it in a different way. We're starting with a very broad model. We still, however, need to have that smaller model that's much more focused. And I think once, and this is a lot of work that's going on right now in my lab and others, is how to actually do that. Once you do that transition from very large language models into focused language models, then you use linguistic rules and analytics and a number of other techniques that will come back, I think, and become very important finally.
Okay. Thank you so much, Larry, for sharing your insights. Ladies and gentlemen, please give an applause to Larry Heck.
Thank you.
Thank you so much.